Hello and welcome to today's experiment. Today I'm going to do the classic Diet Mentos and Diet Coke and Mentos trick. This is a fun trick which you can do at home, outside of course. Now, my experiment today is I'll find out if this trick works, but that's already well known. Now, my aim here is to make this trick better and on a budget too. Now, if you're wondering how it works, I've done some preliminary research to answer that question, mostly watching the Mythbusters episode on it. The main factor is a process called nucleation. Okay? Diet Coke is a supersaturated, and other soft drinks, is a supersaturated solution of carbon dioxide. All that gas is just crammed in there, okay? And it will attempt to escape if it gets the opportunity. Now, the Mentos provides the ability to do that because it's covered in lots of tiny little pits, and these are good places for carbon dioxide bubbles to form. So it bubbles up and it creates foam which spurts out everywhere. Okay? But why Diet Coke? Well, it turns out that, Mythbusters found this as well, that the key ingredient here, which makes the Diet Coke so incredible compared to other soft drinks, is the aspartame, the artificial sweetener. Okay, it does something to lower the surface tension and make it more foamy. Okay, now here's my setup. Okay, over here I have a wall scale, but at quarter-meter intervals because we're in Australia and we use the metric system. And here's a bottle of Coca-Cola Diet Coke. And here are the Mentos. So, enough chit-chat, let's get started. Here I have my two Mentos. Okay? Two whole Mentos. Let's hope it works. And here I have my bottle of Diet Coke, as I mentioned before. Now, we'll open it and hope it doesn't fizz everywhere, because we need a fizz to stay inside until we put the Mentos in. Now, ready? Go on, put them both in at once. Ready? Set, go. And there you have it, the Diet Coke and Mentos trick. Hey, well that wasn't too bad. Go about, what, this high roughly? I'll look at the camera later. Now, the important question to ask though is, can we make it better? Now, you see, the thing about doing this trick is that if you want to do it a lot, you need a lot of bottles, and if you use an expensive brand, that can cost a lot of money. So a good way to save money would be to use a cheaper brand. So here I have a selection of brands of Diet Cola. Okay, here's the Coca-Cola Diet Coke brand, which I used before. This is Pepsi Max, major competitor of Coca-Cola. And here now Coca-Cola is a rather expensive brand. Here are some cheaper brands. Here is Cole's home brand Diet Cola, Woolworth's home brand Diet Cola, and LA Max Ice. All of these contain aspartame, which is why I'm using them. So, let's get to testing. I would expect that all these should have comparable results to the Diet Cola, the Coca-Cola. Use the same number of Mentos. And ready? Dropping. Right. Sorry for the technical difficulties there. That got up to about here. Roughly. It looked a bit underwhelming to me. So, next, let's do this next named brand, the LA Ice. Okay. Again, two whole Mentos, you've got to be consistent. Okay. Ready, steady, go. That was pathetic. You're like, me. Huh. Well, next experiment, next one. So that's the named brands. Time for the home brands. First off, Woolworths. Home brand Woolworths. These are all 1.25 litre bottles, by the way. Here we go again. Ah! That's what we're looking for. And the last brand that I'm testing, Cole's home brand Diet Cola. In we go. That's also good. There we go. Foamy mess everywhere. So those are the brands. And I shall get back to you on those results. Time for my next part of this experiment. Does size matter? As a control, out fell some Mentos. Time to try out the Diet Coke again. There's also the cost thing to do with size. Okay, for example, that is cheaper than this. At the same price as this on its own. You can buy these in bulk. So yeah, this, value for money, this is better in terms of volume, but what about in performance? That's what I'm here to find out. Two Mentos as before. That looked slightly less impressive than before. Oh well, no matter. Next, bigger. Is bigger better? Or will it do the same? We don't know. If anything in my time studying chemistry has told me, is that the rate of reaction is largely dependent on the concentration of the reactants. This is the same as that, except it's just bigger. And, it's maybe bigger will last longer and thus have more mass in the fountain and spew up and stuff. Not sure. I think it's probably more closely tied to the amount of Mentos though. 2 litres with 2 Mentos. That did look bigger. Now let's try smaller. As I said, this is more expensive, oddly. Pretty silly, really. But that's the way of the commercial world. The question is, how much will being smaller impact its ability to do Diet Coke and Mentos? Let's find out. Oh, that was pathetic. That didn't even get a fountain, just overflowed. Final test. A can of Diet Coke is 375 milliliters, so it's even less than before. But would it behave differently? So it's probably not going to do anything particularly spectacular, but would it behave differently because it's a can? I don't know. There's only one way to find out. Okay. This might be trickier to insert them both at once, but I'll give. I'm sorry for the technical difficulties. It turned out the iPad that I was recording on ran out of memory and stopped recording without me noticing. Not good at all. Bad stuff. But the show must go on. So this, which I was just about to do when it cut out, it's all foamed up and just went blah 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 blah. Didn't do anything. Okay, about as impressive as this one. Then I did something different. I poured some from the unopened bottle of 1.25 litre Coke, filled this up. It was very slow to do because it kept foaming up when I was pouring it. No good. And when I put the Mentos in, it was evident that all the bubbles had already escaped because it was really slow and I did nothing but blib, 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 pour over very slowly eventually. And then in my half-full bottle of Diet Coke, I put some Mentos in that also, but it didn't make it out. It got up to the top, but then it ran out of steam and over. So, we know now that more Diet Coke gets you a bit more of the fountain, but it's only a little bit more fountain. Perhaps, to get more fountain, we added more Mentos, okay? Since it is possible that Mentos here is the limiting reactant, and thus by adding more Mentos, we'll get more reaction. So let's take another comparison. So let's just take a quick go with this one, a comparison. 2 Mentos. Okay, ready, steady. That was a bit underwhelming. Still fizzing away. You don't want underwhelming. You want better. Let's say, we get stingy on our Mentos. Okay? Or we only add 1 Mentos. Okay? Let's see if that has any effect. Okay? Bottle with just 1 Mentos. And we see that we get a smaller reaction, as you might predict. So, final test. What are we going to do in our final test? The next step is to double the Mentos. 4. Huh? Maybe we'll get a nice big fountain this time. 4 Mentos. Our trick will be getting these all in at once. That looked better. That looked much, much better. Yes. So as you can see, more Mentos gives you more fountain. Now, what else can we experiment with here? Well, as you may know, the key part of the reaction going on here is the Mentos. Without the Mentos, nothing happens. It just bubbles away like a normal soft drink. The Mythbusters have found that this happens due to something called nucleation. As if you cover it up, it doesn't work. But can we change the Mentos to make it work better? These Mentos, I've sandpapered the surface to remove any possible coating that might be on it. Okay? Now, it's possible that I may have stripped away all the important bits which make this reaction work. So it might work worse, or it might work better, or it might work mostly the same, because maybe nothing's really changed on the surface. There's only one way to find it. And what do you know? It seems to have negatively affected the performance. is perhaps what I've done is I've flattened the surface, at even as tiny at the microscopic level, and that would result in slowing down the reaction. Maybe. Now, that method was a bit experimental, but there's one method which is tried and true in the chemistry world, and that is to powder up your reactants, like I've done with 2 Mentos here. Okay, powdered up, so it vastly increases the surface area, because reactions happen at the surface of materials, where 2 materials meet, that is where they will react. And so if you increase the surface, there's more points where they meet, more points to react, faster reaction, more bursting everywhere. So, big worry here is I won't be able to get it all in time. Come on, in. Well, that's interesting. It appears that by powdering the Mentos, look, it's all floating on top. You can't see it, but I can. Most of the powdered Mentos is actually floating on top still. Okay? And that's a problem, because we want the reaction to happen down the bottom, where it can push all the Mentos up. There's also a problem that I couldn't get it all in at once. So it was added gradually, which is no good. So maybe I'll figure out a way to make that work. But funneling it in, it's a bit sticky, and funneling it in doesn't work. Sadly. I was hoping to get massive eruption because super speed reaction. Nah, no such luck. Yes, as we can see, without adding any other fancy engineering thing, the original, the Mentos as it is better. Now, the next variable I am going to test is the opening. Now, you see, from this thing, this fountain effect would be centered a lot around the idea of flow rate. How many liters per second. Now, it will produce the same amount of liters per second, okay, for a given amount of Mentos and Diet Coke. So thus the flow rate is the same. Okay, but you see, flow rate is equal to the area of the opening times the velocity. Okay, so if the flow rate is the same, then if you increase the area, you lower the velocity, so you get a smaller fountain. But if you lower the area, you get a higher velocity. That's what I'm here to find out. We're going to experimentally determine the difference. There we go. Big opening, 2 Mentos, in. And as you might expect, nothing spectacular happens with the big opening. Just sort of pours out the side. But of course, big opening, nothing much happens. Now, next I'm going to test what happens if you make the opening smaller. You see, I've drilled a hole through this one. Small hole, I have high hopes for this one. As long as I can pull off putting the lid on fast enough. If this doesn't work, this might get messy. Or messier. Okay. Ha-ha! Ah, brilliant! Brilliant! It got all the way up here, up to the 2-meter mark! Do you see that? No, probably not. That probably went off the scale. That got to the 2-meter mark. That's brilliant! 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 That's the kind of results we want to see. final test is another one which may take some doing. I've got a cork here. I'm going to see what happens if I attempt to seal in the pressure. If all goes well, the cork will pop up after it builds up for a while. I'll go spurting everywhere. I should probably grab an umbrella or something. Okay. Here we go. I've got my safety precaution now. Not so much for my safety, but for the camera over there that you're looking from. Okay. So I open this up, put 2 Mentos in, shove a cork on top, and then run over to protect the camera. This might end badly. Okay. Ready? Well, that cork wasn't a very effective seal, now was it? So, in conclusion, this one, with a hole in top, is brilliant. Yes, absolutely brilliant. Okay, my next experiment is going to be centered around temperature. If I heat the bottle, will it make it work better? Or if I cool the bottle, will I make it work better? Well, in chemistry, if you heat up something, it increases the rate of its reaction, and rate of reaction is what we want here, because faster reaction means more vigorous foam. But at the same time, you heat something, makes gases less soluble in it, so the gases might all, so the CO2 might all escape when I open it. Open the hot bottle. I don't know. That's what I'm going to find out. This here bottle I have just gotten out of the hot water bath, okay? So it's warm to the touch at the moment. So, better get ready. Don't know what will happen. Plastic feels softer. And in goes the Mentos. Oh! Hey, it made it work better. What do you know? Who would have guessed? Oh, I did. Here is the cold bottle. This one I've had in the freezer for a little bit. Not long enough to freeze. It's not enough to get cold. So it's cold. Ready, set, test! Yes. You see, cold, unlike heat, which heat speeds up reactions. So it makes sense that if you cool something down, the reaction will go slower. You might change the position of equilibrium, you know, where it finishes, but we're not too concerned about that. We're concerned about how fast it goes. And that didn't go very fast. But back when I did the powdered Mentos, I said I'd need to have an engineering solution to stop the Mentos from just floating to the surface and making sure it all got in at once. So yeah, I have it. This bag, made from chalk, contains 2 powdered Mentos and a stone. Okay, the bag keeps the Mentos all in one packet, so that I can drop it down in a single go. It also keeps all the powdered Mentos inside it. The holes are too small for the Mentos to get out, but liquids and gases can go through it, which means the reaction should still take place. The stone is to make sure it sinks. Okay, challenge of this design is that it doesn't fit inside the lid easily. You in sink. It's not heavy. The stone's not heavy enough. Yep. It doesn't seem to have helped at all. And I think it comes back to nucleation, the results we got from the sandpapered Mentos. You see, I've observed that a Mentos, only the surface is that white stuff, where all the nucleation takes place, and underneath it's sort of generic lolly type thing, which wouldn't be very conducive for nucleation. By powdering it up, we've probably destroyed the nucleation sites, just like we did when we sandpapered it. As such, the reaction was also limited. Ah, well, that thing was hard to get in there, so it's probably for the best it didn't work. Okay, so that comes to the end of my experiments, and I could talk to you about my conclusions, or I could show you. As we've seen, Diet Coke is more or less the best brand, by margin, to use for this experiment. Coca-Cola brand. I've got a big bottle, because bigger is better. I have got all my remaining Mentos in here. I don't know how much I'm going to be able to use for it. I have got here a lid with a small hole. I'm not sure if I'm going to be able to get that on in time, but if I can, that'll be cool. And this bottle I have had in the hot water bath. It's going to be a tricky one, but it's a big one. And when I do it, you might need to look up. Well, let's see how this goes. Wait. That was fast. I don't know how many I got in there until it started. And yeah, that was a good fountain. Note to self, hot water gives you less time to react. And yes, I hope you enjoyed the Diet Coke and Mentos experiments.